So for this video, we wanted to do a quick comparison between SAP IBP's Inventory Optimizer and Demand-Driven MRP, or to keep it simple, IO versus DDMRP. Both help to maintain efficient inventory levels but go about it in completely different ways. First, a couple of disclaimers. DDMRP theory. I encourage you to review some of the YouTube videos on DDMRP in order to get a better idea as to what and why DDMRP works the way it does. I'll link some videos below. Just keep in mind there's a big difference between the DDMRP theory and what you actually end up implementing. Another disclaimer is example versus real-life data. For the purposes of this video, I wanted to compare IBP's IO versus IBP's DDMRP, so I do have a very basic data example. But anyone watching my videos will tell you if you're seriously considering DDMRP or IO for your business, you need to run some real data through your business through the tool, whether that's a proof of concept or a full-blown implementation. It's not a simple question to say DDMRP will give you a 10% lower inventory level than IO or vice versa. Your own business is unique and deserves a more thorough answer before laying down any serious capital for a project. Another disclaimer I have is on current versus future functionality. I'd like to stress that IBP is using an extremely iterative development process, so big pieces of functionality like DDMRP usually do not appear in one release and are 100% fully functional when released the first time. SAP relies heavily on user community input for which direction to take a particular piece of functionality, so don't be too concerned about a piece of missing functionality. But also be aware that DDMRP is one of the first pieces of IBP functionality that have been developed by a third party, Camelot Labs to be exact. So it's hard to tell what the future development of DDMRP is going to look like, or if even additional development is even required. We do have an IBP roadmap, but that can only tell us so much. Finally, my last disclaimer is on IBP basics. The video is assuming you have some basic knowledge of SAP IBP, so if you don't, feel free to search my other videos for any, or really any video on SAP IBP. So starting with the difference in inputs and outputs between IO and DDMRP, IO calculates a safety stock and additional key figures based on various inputs like customer service levels, variability rates, lead times, lot sizes, and most importantly, forecast and forecast error. Although the primary output is a safety stock quantity, there are also a host of other IO outputs. But don't worry too much about the details. IO's first job is to use forecast and forecast error to derive a safety stock quantity. Some DDMRP inputs are either identical, for example, periods between review, indirectly related, like transportation lead time, or unique, actual sales, from IO inputs. But there are also a host of others that are unique to DDMRP. These inputs are used to generate 3 inventory levels or bands. You could almost call them reorder points, but I'm sure I'll get in trouble with the DDMRP Institute. Again, don't get too hung up on the details at this point. Suffice it to say it uses historical actual sales to set those bands, and does not generate any replenishment orders until inventory levels start to fall out of the green zone from actual order sales. The next difference between IO and DDMRP and IBP is how integrated the functionality is with other IBP planning modules. IBP IO has been part of SAP's unified planning area for several years, which means that the IO functionality is already integrated into the demand planning and supply functionality. In other words, it's pretty seamless to take the demand from demand planners, calculate your inventory levels in IO with the same master data, and then send them off to the supply planners for their planning. In the case of DDMRP, the functionality sits in its own SAP standard and separate planning area. Nothing says that you can't take this functionality and add it to the unified planning area, but the point is that there's still those extra steps to walk through and figuring out exactly how to integrate it into your wider process. And it's always nice when SAP has done the hard work of that integration and learned from other customers, instead of you having to invent or reinvent the wheel. But also keep in mind that DDMRP is its own process. In other words, It reacts to actual inventory and sales orders, which is completely different than planning out a supply plan based on expected future demand. So stay tuned on that one. Who knows? It might just appear in a unified planning area in the next release. Somewhat related to DDMRP not being part of the unified planning area, the other major difference between IO and DDMRP is what you're going to actually do with the outputs. Remember, IO has safety stock, and DDMRP has 3 inventory levels. So in IO, you are usually just going to send that safety stock quantity as a dependent demand requirement. And if the safety stock value changes, then you might have a delta of that change as a new requirement in the future. With DDMRP, you're going to have a replenishment requirement when and if a sales order comes through to drop you out of that green zone. And the priority will not be based on due date, but by priority, or how far you're into the yellow or red zone. Another big difference between IO and DDMRP is the complexity of the calculation. IO is based on a pretty complex statistical calculation that takes a bit of time to become comfortable with. Whereas DDMRP is a pretty simple calculation for each zone. That difference may not sound like a big deal, but it could mean the difference between spending 9 months kind of understanding a black box versus just having your subject matter expert tell you the calculation in an hour's training session. Again, this is not an endorsement of one method over another. I'm just pointing out the differences that you should plan for. There's one last difference between DDMRP and IO that I wanted to talk about, and that's decoupling points. In DDMRP, you can create decoupling points. So instead of having an extra lead time from finished to raw products, you can actually break down that link in order to shorten the lead times or to better respond to short customer tolerance times. You're probably seeing the pros and cons of both approaches already, which is probably a whole other video or series. One other clarification. There are 5 steps to the DDMRP process, and to be clear, with DDMRP and IBP, as of this release, I see IBP only fulfilling the first 2 to 3 steps of a 5-step process. In other words, you'll need to interface with R3 or S4 in order to complete replenishment. That also gets into another whole discussion about how this would work with IBP response. But again, just trying to keep this video short and sweet. So you can see here the inputs for the inventory optimization side. Quick example, IBP 100 is the product. It is manufactured in location 1710, shipped to 1720, and then goes out to the customer group, private customer. Starting at the bottom, you can see that the demand forecast is 686 for the week till the foreseeable future. The demand forecast error you don't see, but that's because week 32 is not the current week, it's week 30. It's at 25%, and the target service level is relatively high at 99%. You can also see the lead time of both for transportation and for production. The lead time errors for production and transportation are 0.25. I know they look like 0, but that's just because of formatting. And then the periods between review is 1 week. And then as I go through the outputs, I run the heuristic. I come up with these values. Again, 1710 was the manufacturing site. 1720 is the warehouse, so to speak. First, you'll notice that the recommended safety stock takes a little bit of time to ramp up, but about 6 weeks in, it flattens out. 646 at the warehouse, 116 at the manufacturing site. IO will break down that safety stock into demand, supply, and service variability. So you can see at the production site, there's no demand or supply variability. It's just a service variability, whereas the majority of the safety stock in the warehouse is due to demand variability. You can also see the cycle in the pipeline stock. For example, it's 0 at the production facility because there's the production cycle is 1 week. 2 other key figures are in play, the target inventory position and the average inventory position. Target inventory would represent what inventory needs to exist at the beginning of the period. The average is obviously for the average over the PBR lifecycle. So you can see for 1710, the production facility, you have a target inventory of 1488, and for the DC, you have 2018. That'll become important. Switching over to the DDMRP side, you can see that there's a new key figure, average historical usage, but you can see everything else is similar to IO. The transportation lead time, same story, IBP 100, 1710 makes the product, 1720 is the warehouse. So the average historical usage at the DC is 97 units, that's per day. So that equates to the forecast on the IO side. You can see lead time of 1 for transportation at 1720. Production is 1. Lead time, you can see now I did a better job on the formatting. So 0.25 on the production, lead time variance, and the transportation variance. PBR of 1. The other inputs, you're probably going to back and forth what inputs are missing. Obviously, I don't have forecast in this, forecast error, and I don't have a target service level either. So in the other example, it was 99%. There's no concept of target service level. There are some inputs around customer tolerance and things like that, but I wanted to, again, keep this video relatively simple. Switching now to the outputs of DDMRP, you can see that these are now totally different than what you saw in IO. You now have a red zone safety and base, and you have a yellow zone and a green zone. And they also will calculate for you the, it's easier if you start at the bottom, top of red, top of yellow, top of green. So in other words, if you imagine for this example, if the red zone, top of red is 903 at 1710, therefore, if my inventory goes below 903, then I'm in the red zone. If it goes below 1590, I'm in the yellow zone, and if it goes below 2278. So that should be the, almost equate to the inventory target, but we'll talk about that here in a second. But there again, 1720 and 1710 both have inventory values for this. So for this slide, since the planning areas for IO and DDMRP are not in the same one right now, I had to just do a manual kind of spreadsheet. And normally if they were in the same planning area, you would have just been able to whip out a planning view really easily. So it's by IO and DDMRP, 1710, 1720 in the total. You can see for IO, the safety stock was 762 total between the two locations. And remember, 1710 is the producing location, 1720 is the distribution center of the warehouse. Its safety stock is not applicable for DDMRP. And then same thing goes for IO. The top of the green, yellow, and red are not applicable, but I've just copied over the values for DDMRP. You can see that they're identical to each other, and we'll talk about more about this in a second, but it's because the two locations are decoupled from each other, so they share the same inventory levels and they have the same inputs basically. So 2278 is top of green, 1590 top of yellow, 903 top of red, and the totals are over there in the next column. The important thing is that 4556, that really kind of represents the target inventory position now. For DDMRP. Which is just 2278, the tops of greens for each location. You can see for IO that the target inventory was 3506 total. Target inventory represents the safety stock, cycle stock, and pipeline stock, as it does for top of green and DDMRP. So you can see that there was a total of 3506. So already you're saying, there's 1,000 units savings or whatever, but don't get too far ahead of ourselves yet. Average on hand is cycle stock plus safety stock, but the average of that. So an example would be I have a forecast of 100 for the week, and a PBR is a 1, so I'm going to have an average of 50 because it's 100 at the beginning, it's 0 at the end. That kind of basic kind of average. So in this case, I've got an average on hand of 802 and 990 at the two locations. and the total average on hand for IO, which is really kind of the best number to compare against, I would say, is 1792 versus DDMRP, which is 1246 for both locations for a total of 2492. This is one reason why I put the disclaimer at the beginning, and I'll just state it again. You got to put in real data in this thing to really understand why one would be higher than the other. And they're not exactly like for like, even though average on hand is a shared key figure between both of them. There's some subtle differences, I think, between the two in both of these cases. And then the only thing else I would add is that there's a lot of reasons why this difference could occur. On the IO side, you could have it higher due to the target service level. In this case, the data example I had was a 99% target service level. Can't go much higher than that. And again, DDMRP, if you were decoupling locations, if you're playing with your customer tolerance times and things like that, you're definitely going to get some different values on that as well. So that's it for this video on DDMRP versus IO. Let me know in the comments what questions you might have, or what you have around DDMRP or want to see with DDMRP or IO, and I'll try to get to those videos as soon as I can. Thanks.